Welcome back to the deep dive. You know how we do it here. You're looking for that shortcut, that concentrated dose of knowledge to get you smart and fast about the critical shifts that are happening right now.
And there is no bigger shift.
No, absolutely not. If there's one engine that is just driving everything,
Right.
the global economy, technology, even policy, it is without a doubt artificial intelligence.
It is absolutely the pivotal force. But, if you look just past the headlines, the ones about the latest models or the newest breakthrough,
Right.
you immediately run into the central constraint, the real problem, and the core challenge. I mean, it's no longer about inventing the next generation of AI.
We're past that in a way.
We are. The challenge now is about having the people, the specialized talent who can actually deploy that technology, who can maintain it, and maybe most importantly, who can govern it. The demand for AI skill is just booming, and it is completely overwhelming the system we have globally.
And we're not talking about, a slight hiccup in hiring, like, oh, it's taking us a few more months to find an engineer. This is a structural crisis.
It's systemic.
It really is. I mean, you have major global institutions, the OECD is a big one, highlighting this exact issue. They're emphasizing what they call a critical and increasingly pronounced gap between the need for skilled AI professionals and the available talent pool.
It's a supply chain problem.
Exactly. It's a supply chain issue. But instead of microchips, the scarce resource is highly specialized human intelligence.
And that's a resource you can't just ramp up production on overnight. Traditional educational pipelines, the ones that have reliably produced engineers and coders for decades, they just lack the agility. They don't have the specialization that AI feels demand today.
Right.
I mean, think about it. The job titles we're desperately trying to hire for right now, MLOs, engineers, AI ethicists, differential privacy specialists,
Things that didn't exist 5 years ago.
they barely existed. And you have academia trying to adapt on a 5-year degree cycle to a field that completely reinvents itself every 18 months. The math just doesn't work.
In that structural mismatch, that's what brings us to our mission for this deep dive. We are going to analyze how one major region, Europe, is confronting this pressure head on.
And they're in a fascinating position.
They really are. They're juggling these very high regulatory standards like GDPR with this intense drive for innovation. And their response isn't just, a general call for more STEM graduates. It's a really complex range of what our sources are calling experimental educational initiatives.
And these experiments are absolutely critical to understand. They represent a targeted, proactive, and really innovative response that's designed specifically to bridge this talent gap. And it's designed to do it across the entire lifespan of a professional.
Okay, so that's the key, not just at the university level.
Not at all. And here's why this matters to you, to anyone listening.
Right.
For any global business, I don't care where in the world you are, if you are trying to figure out how to staff your AI projects,
Right.
how to stay competitive, these European efforts, they offer a crucial, actionable blueprint.
A blueprint for what exactly?
It's a blueprint for how you shift from desperately trying to hire talent in a scarce market to strategically cultivating it in-house.
So we're going to unpack that blueprint. We're going to explore the really radical scope of these initiatives. I mean, from primary school literacy all the way up to urgent professional reskilling. And then we're going to translate those big continental policy lessons into practical, immediate strategies for your organization.
Exactly.
Okay, so let's start by drilling down into the scale of this crunch, because I think understanding the urgency is what dictates this sheer scale of the solution that's needed.
It does.
I mean, every sector, and I mean every single one. You've got finance, precision agriculture, personalized medicine, industrial logistics. They are all suddenly reliant on advanced AI optimization, on machine learning deployment, complex data science. It's not a niche tech sector thing anymore.
No, it's a foundational layer of the modern economy.
Yeah.
And the scale of knowledge transfer required is just unprecedented.
Yeah.
I mean, when we really dig into those reports, especially the ones flagged by the OECD, that pronounced gap they identify,
Yeah.
it isn't just a lack of warm bodies with computer science degrees.
Right. It's more specific.
It's a specialized knowledge deficit. It's a speed and relevance issue. The skills that are commanding the absolute highest salaries right now are hyper-specialized, and frankly, they're ephemeral. Their shelf life is short.
Okay, so give us a flavor of that. What does that hyper-specialization actually look like? If I have a degree in software engineering, a good one from a good school, why can't I just pivot to an AI run?
Because modern AI development is just fundamentally different from traditional software engineering. It's a different paradigm. You need engineers who understand the the really deep nuances of things like large language model fine-tuning.
Okay.
And that's not just programming, it's prompt engineering, it's data curation at a massive, massive scale. It's understanding transformer architecture under the hood. Or, okay, take another example. Specialized computer vision for autonomous manufacturing robots.
Right, like on a factory floor.
Exactly. That requires this deep fusion of mechanical engineering, optics, and cutting-edge deep learning. These are highly specific skill stacks that you just don't get in a generalist degree program.
And so the entire global market is effectively fighting over the, handful of people who happen to possess these very specific stacks of skills.
That's the bidding war.
Yeah.
And that scarcity, it drives up costs astronomically, creates intense churn as people jump from company to company, and ultimately it just slows down the entire adoption cycle for essential innovation within companies.
You can have the best idea in the world, but if you can't hire the team to build it, it's just an idea.
That is the fundamental urgency that's driving Europe's strategic response. They looked at that situation and they realized that waiting for the traditional university system to maybe eventually catch up, that was not a viable economic option.
They'd be left behind.
Completely. They recognized that the systems that produce generalized engineers, they just weren't built for a field where the entire knowledge base shifts radically every time a new foundation model drops.
So their answer is to pioneer these experimental educational initiatives. When we use that word experimental, it implies a really radical departure from the norm. What are the key characteristics that make these experiments different?
Well, experimental here really means two things. First is agility, and second is a cross-disciplinary focus. It signals a willingness to deploy knowledge really rapidly and in unconventional formats.
Okay, so it's not just about adding another computer science 101 course to the catalog.
God, no. It's about dismantling the traditional, rigid curriculum boundaries that have defined education for a century. The silo between the engineering department and the law school, for instance, that has to come down.
So we are talking about moving beyond the standard four-year degree as the sort of default entry point into the profession.
Absolutely. Think about the specific mechanisms of these experiments. Our sources highlight several key strategies being adopted across various EU member states. One of the biggest is the explosive growth of intensive short-term certification programs.
Boot camps.
Sort of, but more advanced. They are often run in direct partnership with industry consortia. So these aren't just generic coding boot camps. They are highly specialized micro-credentials focused entirely on, say, cloud deployment of machine learning pipelines, or specialized industrial AI maintenance for Siemens hardware. Very, very specific.
That is a direct response to the immediacy of the business need. I mean, companies need those specific skills now, not some generalized theory that might be applicable later.
Precisely. Another experimental avenue involves massive open online courses, MOOCs, but with a twist. They are being integrated seamlessly with structured industry mentorship programs.
So it's not just watching videos online by yourself?
No, the knowledge is accessed online, so it scales infinitely, which is great. But the practical, applied expertise is provided through direct mentorship or project-based learning that's actually sponsored by companies. So you're working on a real problem.
That model sounds like it allows for really rapid skill acquisition and, I guess, verification. It enables a professional to pivot their career in, 6 to 12 months instead of 4 years?
That's the goal, that flexibility and speed. That is the signature of this experimental approach. It's a recognition that learning doesn't just happen on an academic calendar anymore. It has to be continuous. It has to be responsive to market shifts, almost in real time.
And critically, you said these initiatives are targeted.
Extremely targeted. They are specifically designed to bridge this gap in these high-demand, high-complexity niches. They're not trying to create more of what already exists. They are laser-focused on producing the exact specialist that the market lacks.
Can you give an example of one of those niches?
Sure. A great one is creating specialized programs focused on AI, auditability, and transparency. Everyone knows regulation is coming, right?
It's already here in many ways.
It is. So professionals who can actually handle that compliance mandate, who can audit a black box algorithm and explain its decisions in a way that satisfies a regulator, those professionals will be among the most valuable people on the planet. And Europe is building programs specifically for that role.
It seems like they recognized the problem wasn't a shortage of interest in AI, but a shortage of pathways. They are literally building new, faster ramps onto the AI superhighway.
That is the key takeaway from this first part. They are optimizing for speed and relevance. They saw the global market fighting over the same small pool of PhDs from the same few universities and realized the only sustainable solution was to create new talent from within their existing population base using these agile experimental frameworks.
Okay, that gives us the urgency and the definition of the solution.
Hmm.
But creating deployable talent, I mean, that requires more than just a quick, intense boot camp. You need a foundational structure. So what exactly are the components of this pipeline? Where does Europe begin laying the groundwork for this kind of continuous talent development?
Well, the brilliance of the European strategy and what really makes it a comprehensive blueprint is that they didn't just focus on one educational level. They didn't just target universities.
Right.
They adopted a multi-pronged integration strategy, and it covers the entire educational spectrum. They are building a robust, continuous pipeline of talent that starts essentially in grade school and extends through the entire working life of an individual.
That continuity seems absolutely vital. Because if you only focus on the output, the finished graduate, you miss the opportunity to cultivate the necessary foundational mindset really early on.
You can't wait until a student is 18 to introduce them to computational thinking. It's too late.
So you have to start younger.
Precisely.
Yeah.
So let's look at that first integration point. School curriculums. The whole discussion here is about incorporating AI concepts early in standard K-12 schooling. And to be clear, this is not about teaching primary school children how to build deep learning models.
Of course not.
It's about preparing students from the ground up for a world that is completely saturated with intelligent technology.
Okay, but how does that actually manifest in a typical K-12 setting? What's the practical difference between, say, standard computer literacy, which we've had for a while, and these new AI concepts?
That's a great question. So standard computer literacy might focus on how to use software, how to use a word processor, or maybe some basic block-based coding. AI concept integration focuses on the source and the consequence of algorithmic decision-making.
Why behind it, not just the how.
Exactly the why. It means focusing on core concepts, like data literacy, helping a 14-year-old understand how their data is collected every minute of the day, how that data feeds these systems, and what the implications are for their privacy.
So it's critical thinking.
It's also about introducing the concept of algorithmic bias. I mean, this is huge. How do you teach a teenager that imperfect data collected from an unequal world, will lead to imperfect and unequal outcomes from an algorithm, and teaching them to question the outputs of the systems they interact with every single day, from their social media feed to their search results?
That builds what you might call crucial digital citizenship. It ensures that students aren't just passive consumers of AI, just accepting whatever output an app provides,
Right.
but rather they become active, informed participants who actually understand the mechanisms and the potential failures behind the technology.
It is essentially cultivating critical thinking skills, but tailored for the digital age. And by integrating this so early, you build a foundational data-aware mindset that then feeds all the later stages of the pipeline. So the students who are entering university, they are already conceptually mapped to the AI landscape. It makes their specialized learning later on so much more efficient and effective.
And that smooths the pathway right into the next stage, which is the traditional core pipeline universities. But, we already established that traditional university education is struggling to keep pace. So how is higher education being specifically adapted to meet these high-speed, evolving demands?
University education has to become far more agile and, I think, critically radically interdisciplinary. Simply offering a 4-year computer science degree that is focused solely on theory, it's just not sufficient anymore. The new model demands application, and it demands cross-domain expertise.
So what does that actually look like on a university campus? Is it just new course names?
No, it's a structural change. It manifests in a few ways. Firstly, you see the proliferation of specialized AI degrees that fuse disciplines together. Think about joint programs in AI and public policy, or bioinformatics and machine learning, or financial modeling with AI.
So the goal is not just to teach the algorithms.
No. The goal is to teach the application of algorithms within a complex, regulated professional environment.
So an AI professional who wants to work in the legal sector isn't just a coder who happens to get a job at a law firm.
Exactly. They are trained from day one in how AI intersects with jurisprudence, with compliance, with the ethical standards that are specific to law. They speak both languages.
Okay, that makes sense.
And secondly, universities are shifting heavily toward project-based learning and what they call industry immersion. So instead of purely theoretical exams at the end of a semester, degrees now emphasize these long-term capstone projects that are either sponsored by or co-developed with local industries.
So the curriculum is being shaped by real-world problems.
It ensures that the skills being taught are immediately relevant and deployable the day you graduate. And it also speeds up the adaptation cycle for the university itself, because the curriculum changes are being driven by immediate industry feedback that's embedded right within these projects.
That sounds like a necessary but probably a very challenging overhaul for these traditional academic institutions that are used to moving pretty slowly.
It is incredibly challenging, but it's also necessary for their survival in this market. They are moving away from the isolated lab model to an integrated, practical, problem-solving model.
Okay, so K-12 creates the foundation. Universities create the researchers and the deep specialists. But there's one area you mentioned that is maybe the most vital for immediate business impact.
Right, and that's vocational training and reskilling.
This is where it gets really interesting to me because vocational training speaks directly to the immediate shortage that businesses are facing today, right now. What's the scope and the mechanism of this pillar?
So vocational training, in this new context, implies practical, applied expertise. It's often achieved through technical schools, these intense boot camps we talked about, apprenticeships, or even corporate academies built inside companies. This is the rapid reskilling pathway that targets the existing workforce.
So not 18-year-olds, but 40-year-olds.
Exactly. This is the mechanism for providing immediate applied expertise that industries need right this second.
So how does this address that existing workforce? I mean, we have millions of experienced professionals out there, managers, analysts, engineers, whose domain knowledge is absolutely invaluable, but whose technical skills are suddenly becoming outdated by these new AI tools.
That is the core implication and the core opportunity for reskilling. Let's take an example. A seasoned manufacturing production manager. She's been on the floor for 20 years.
Knows everything about the process.
Everything.
Yeah.
She doesn't need a 4-year PhD in data science. It would be a waste of her time and talent. What she needs is a 6-month intensive course on how to deploy and interpret the output of predictive maintenance AI systems for her specific machinery, or how to optimize the supply chain logistics using the new machine learning tools the company just bought.
It's highly contextual training. It's leveraging the domain expertise she already has.
Precisely. And this approach rapidly injects relevant, job-ready talent directly back into the market. It mitigates that immediate, urgent shortage by upgrading the people who already understand the business context, which is often, half the battle in any successful AI deployment.
And how did they track this? How does an employer know that this 6-month course is any good?
That's where microcredentials come in. They're often verifiable, sometimes through blockchain or through standardized national frameworks that Europe is developing. It makes these new skills transparent and immediately recognized by employers. It's a trusted signal.
So if we synthesize this entire structure, you've got K-12 building informed citizens. You have universities creating these highly specialized interdisciplinary researchers. And then vocational training is rapidly reskilling the existing domain experts. I mean, it's not just an education system. It sounds like an economic resilience system.
And this brings us to the really critical distinction that's noted throughout the sources we looked at. The focus is not merely on increasing the sheer numbers of graduates. It's not a numbers game.
Right.
If you just churn out vast quantities of people who only possess basic coding skills, you haven't solved the core problem of specialization and relevance. So Europe is intensely focused on the quality of the AI education being delivered. They're trying to build something far more resilient than just a technician.
They're cultivating the specific characteristics needed to thrive in what is a very complex, a very regulated, and a very rapidly changing technological landscape.
Yes, they're building a complete professional.
So we've established that this focus on quality control in Europe demands more than just, technical depth. They're really trying to define the next generation of AI professional, this well-rounded professional, by adding a crucial layer of competence on top of the technical skills.
This holistic approach it's arguably the most defining element of the entire European blueprint, and it holds tremendous strategic value for global businesses that are paying attention.
So let's break that down.
Well, while the technical skills, knowing how to build, how to optimize, how to scale systems, that remains the mandatory baseline.
Table stakes.
Exactly, table stakes. The essential overlay is the mandated training in understanding the ethical and societal implications of AI.
Now, for a global business that is focused on quarterly results, Why is this mandate integrated so deeply into the technical curriculum? I mean, why can't ethics just be a one-off HR seminar that you click through once a year?
Because the challenges that are faced by AI systems today are not purely technical bugs. They're inherently socio-technical problems.
Socio-technical.
Yeah.
Unpack that.
If you are building a system that affects people, and almost all of them do, whether it's a hiring algorithm, a loan approval system, or a system that's being deployed in public health, the ethical framework, the compliance mandate, the potential societal impact, those things are inseparable from the technical design of the system itself.
Okay, let's elaborate on that concept of the socio-technical challenge. Can you give us a detailed, real-world example of a scenario where a purely technical professional fails, but a holistic professional would succeed?
Absolutely. Let's consider a major financial institution. They're developing an AI model to assess loan defaults. A purely technical team, a very smart one, might optimize that model ruthlessly for predictive accuracy. And they might achieve, say, 98% correlation with historical data, a huge success technically.
That's great.
But what if that historical data reflects systemic biases? What if it reflects discriminatory lending practices from decades past, which we know it often does?
Right, so the data itself is skewed.
The data is skewed. So the technically accurate model will simply learn, automate, and then scale that historical unfairness at a speed and scope humans never could. The resulting model is technically excellent, but it's socially harmful and, crucially for the business, legally problematic.
And potentially completely destructive to the company's reputation and its bottom line when it gets out.
Precisely. Now, a holistic professional who's been trained to integrate these societal factors applies what's called ethics by design. They don't wait until the model is built and about to be deployed to check for fairness.
It's not an afterthought.
It's part of the blueprint. They integrate techniques like differential privacy and fairness metrics during the data preparation and model training stages. They build in auditability and transparency tools from the absolute outset because they know that eventually they will need to explain why the machine made a certain decision, especially in a regulated environment like finance.
That seems absolutely critical, especially when we talk about high-stakes decision-making. The ability to explain and defend an AI decision, that transparency and accountability, it's fast becoming a mandatory feature, not some optional extra.
It absolutely is. Europe is preparing professionals who are uniquely equipped to tackle the complex challenges of tomorrow, because those challenges are defined by this convergence of technology, law, and human impact. They understand that non-compliance isn't some abstract future risk. It's an immediate business operational failure.
So if we look at regulatory compliance, I'm thinking particularly around data privacy, like GDPR, that's a perfect example, right? A professional without this holistic view might build a fantastic model that, whoops, uses too much granular personal data, making it immediately unusable and illegal in all European markets.
That is the most direct and immediate business payoff. A team that's trained holistically builds systems that are compliant, defensible, and trustworthy right from the design stage. And think about the money that saves. They save the company massive costs down the line in retrofitting, in legal fees, or the ultimate price. Complete system abandonment because of public outcry or regulatory fines.
So they view accountability and transparency as design specifications. They're just as critical as speed or accuracy.
Yes, and it means the professional was required to possess critical thinking, foresight, and a sense of shared responsibility, not just raw coding ability. It really shifts AI from being this isolated engineering function to a foundational business and societal function.
The critical takeaway here, then, is that this focus ensures that AI development proceeds responsibly, benefiting society while still driving innovation. It's a recognition that actually responsible development is the only sustainable way to drive long-term, trustworthy innovation.
That's it. Europe is essentially embedding risk mitigation directly into the talent they produce. And any company that hires that talent automatically gains a competitive edge in resilience and in trust.
It signals a real maturation in the field. I mean, the days of just move fast and break things, of just building the fastest algorithm regardless of the downstream consequences, those days are over. The next generation of success is going to be defined by the ability to manage complexity across these socio-technical boundaries.
That's where the value is now.
Okay, so we've analyzed the strategic pressure and this really sophisticated response that Europe is executing across its entire educational system. Now, let's get practical. Let's translate this into actionable strategy. How can a global business operating in these highly competitive markets actually use this European blueprint?
The very first step, I think, is just acknowledging the immense persistent business challenge. As our sources reiterate over and over, companies face immense difficulty in the competitive and limited external market when they're trying to find AI talent.
It's a battlefield out there.
It is. The competition for the few truly specialized professionals is unbelievably fierce. Salaries are becoming unsustainable for many companies, and staff retention is incredibly volatile. People are constantly being poached. You simply cannot build a long-term AI strategy by relying solely on constantly poaching the few available experts.
No, it's an inflationary zero-sum game. So if you can't buy the talent reliably, you must commit to building it.
That is the philosophical shift that is required. The blueprint for cultivating their own AI talent, which we can derive directly from Europe's strategy, involves actively and strategically investing in education and training within the company structure itself.
That's a strategic imperative.
It means internal cultivation has to move from being a line item in the HR budget, a cost center, to being a core strategic innovation investment right alongside R&D.
So that means looking inward. Companies have to mimic the European model. They have to identify their existing workforce, their domain experts, their analysts, their experienced engineers, and provide that targeted vocational-style high-intensity training to convert them into bespoke AI specialists for their own needs.
In this internal investment strategy, it offers fundamental advantages that external hiring just cannot match. Let's outline the first major benefit, which we can call benefit A, the immediate shortage solution.
Okay, so how does internal upskilling solve the current urgent skill scarcity faster than just trying to hire someone?
Because the time to value is dramatically shorter. I mean, think about it. When you upskill an existing employee, let's go back to our example, a 10-year veteran of your manufacturing floor, they already possess irreplaceable domain knowledge.
Right.
They know your systems, your data quirks, the political landscape of the company, and the end-user pain points. You only need to teach them the specific AI tools, like how to interpret and act on the outputs from a machine learning model. The context is already there.
Whereas an external AI hire, no matter how brilliant they are technically, they're going to spend their first 6 months just learning the operational intricacies, the proprietary data structure, and the company culture before they can be truly effective.
Exactly. Internal talent is already context aware, so they can deploy solutions that are immediately relevant and tailored to the unique environment of the business. This directly addresses the current urgent skill scarcity by activating this massive, underutilized internal resource pool that most companies are just sitting on.
And the second benefit, you said, moves beyond the immediate crisis and speaks more to long-term resilience. That's benefit B, fostering longevity and adaptability. This strategy fosters that desired corporate culture of continuous learning and adaptability.
This is how companies future-proof themselves in the age of AI. I mean, in a field where the necessary skill set changes every single year, relying on static degree-based credentials from 5 years ago is a strategy that is doomed to fail.
Right.
If a company embeds a culture where learning, reskilling, and credential acquisition are routine, where it's a mandatory part of the job description for technical staff, they build incredible resilience into their organization. They can pivot when the next major technological wave, whether it's quantum computing or new model architectures, hits the market. They're not caught flat-footed.
So the investment is not just in a specific skill set for today, but in the entire organization's metabolic ability to evolve indefinitely.
That's a great way to put it. Continuous learning and adaptability are identified as the key ingredients for success in the fast-evolving world of AI. Now, implementing this, it requires a dedicated strategy. It's not just about giving people a subscription to a learning platform.
What does it require?
Often it's through the creation of internal AI academies or structured mentorship programs that pair senior external consultants with high-potential internal employees for accelerated knowledge transfer. It has to be structured and intentional.
That brings up the practical question of resources, though. How should a business approach budget allocation for this kind of internal AI pipeline?
It needs to be treated as a strategic R&D investment, not a training expense. That's the key mindset shift. Companies should dedicate specific resources to developing a curriculum that's based on the specialized, niche skills they actually need, replicating that targeted focus we saw in the European vocational sector.
So not off-the-shelf courses.
No. This might involve budgeting for cloud computing credits, specifically for employee training and sandbox projects, or it might mean carving out 10–20% of employees' time for continuous learning modules and, critically, applying that learning to a real internal project.
It's a fundamental commitment, then. You're essentially paying your employees to learn skills that you know will probably be obsolete in 2 years with the understanding that they will then need to learn the next iteration of skills after that.
That is the cost of staying competitive in this field. But the return on that investment is massive. You get reduced attrition because people want to work for companies that invest in them. You get higher employee satisfaction, you get faster innovation cycles, and you get access to unique, bespoke talent that is perfectly suited for your specific organizational challenges.
And I imagine by implementing that holistic, risk-aware training program internally, companies are also ensuring they're aligned with the regulatory direction of major global markets like Europe.
That preemptive compliance is invaluable. You're not just building tech, you're building trustworthy tech.
So ultimately, the message is that businesses can stop relying solely on this competitive, expensive, and limited external talent hunt. They can start proactively building the high-quality, specialized talent they need, ensuring they can stay ahead of the curve.
It transforms the human resources function from what is often a cost-intensive hiring department into a strategic innovation driver that guarantees future capability.
And this kind of commitment, it must signal confidence. Confidence that you can retain the talent that you train, and confidence that your investment today will translate directly into market leadership tomorrow.
It's the only sustainable path forward.
Okay. We have covered a substantial amount of ground in this deep dive. We've really extracted a powerful, multi-layered blueprint from Europe's response to the AI skills crisis. And I think this is a framework for talent cultivation that every single organization should be analyzing right now.
We began with that immense global demand gap, the one highlighted by the OECD, which demands this radical evolution in education, the traditional academic model.
Yeah.
It's just too slow, it's too generalized to survive in this environment.
And Europe's solution, we saw, is this multi-level response. It's integrating data and AI concepts into school curriculums for that foundational literacy. It's radically adapting specialized university degrees to be interdisciplinary and applied. And crucially, it's leveraging rapid vocational training and micro-credentials for the urgent reskilling of existing professionals.
And the defining feature of the talent that this pipeline produces is that emphasis on holistic quality. It's about moving beyond mere technical proficiency to demand that professionals understand the necessary technical implementations of compliance, of accountability, and of the broader socio-technical challenges that come with any deployment. This creates resilient professionals who inherently mitigate risk for their employers.
And finally, we translated all of that into a clear, actionable blueprint for global businesses. Stop struggling in the limited external market and start proactively building your own talent. Investing in internal education addresses the immediate skill shortages and, maybe most importantly, it fosters that culture of continuous learning and adaptability that is essential for long-term success.
The core message is really clear. Adopting these educational innovations, whether you're doing it at a national scale or within a single corporate structure, it's not optional anymore. It is the critical differentiator for sustained success. It ensures long-term adaptability rather than just short-term reliance on expensive external hires.
And that leaves us with one provocative thought for you to carry forward, building on everything we've discussed today. If ethical, compliant, and socio-technical understanding is now being integrated into AI education pipelines across an entire continent, if that is setting a rigorous new standard for the next generation of professionals, what immediate transformative responsibility does that place on current business leaders who hire and deploy AI systems today, especially those systems built by professionals who lacked that holistic risk-mitigating training? The standard has been set for the future. The lag in today's workforce has to be addressed immediately if you want to compete.
Indeed, it forces every company to audit not just its technology, but the training and the mindset of its technologists. Thanks for joining us for the deep dive.
We'll see you next time.